Now our motto determine V naught with the help of Thevenin's equivalent, Thevenin's theorem. Okay, so how can we determine? First of all, we have mentioned that is x and here y. Okay, 1 kilo ohm resistance is parallel to the V naught, so that is it's behave as a dummy resistance. That's why first of all we have make Thevenin's equivalent corresponding to xy terminal. After that adding RL load. RL load means 1 kilo ohm. Okay, now so start first of all we have focus on RTH, after that VTH. Okay, now how can we determine RTH? All independent source reduced to be 0. All independent source, that is open circuit, this one is open circuit and this one is also open circuit. Okay, so first of all make here that is 1 kilo ohm open, here also open. Okay, and that is 1 kilo ohm, here 1 kilo ohm, here 1 kilo ohm, here 1 kilo ohm, and this is also 1 kilo ohm, and that is open circuit simply, and that is load resistance. Okay, that is x and y. Our motto determine RTH. So what about RTH? RTH is 111 or 3 kilo ohm. Very simple. Okay, this is open circuit, this is open circuit. If you take current and this current path follow this path, it means these three are series. That's why. Okay, so what about RTH? RTH is 3 kilo ohm. Clear or not? After that our next target is VTH. Our next target is VTH. How can determine VTH? I know that first of all redraw the circuit. Redraw the circuit. That is 2 milliampere, that is 1 kilo ohm, here 1 milliampere, and this one 1 kilo ohm, here 1 kilo ohm, that is 1 kilo ohm, and that is 1 milliampere, and this is open circuit, and our motto determine VTH corresponding to XY terminal. Okay, so our next target is our motto determine VTH. So how can determine VTH? If follow this path, or you can say that you follow this path. This is unknown voltage, this is current source, this is unknown voltage, so we have follow this path. Now what about current? That is I1, we have taken I2, here take I3, loop current I1, I2, I3. What about I2? Loop current I2 is 1 milliampere. So I1 is, I2 is 1 milliampere. I3 also 1 ampere, 1 milliampere, and I1 also 2 milliampere. Clear or not? Okay, this loop current follow this branch. I2 this equal to 1 ampere, I1 is 2 milliampere, and what about I3? I3 is 1 milliampere. Now we have focus on VTH path. Follow this path means here current direction I2, so positive negative, that is I2. Okay, now follow this path. If I3 is greater than I1, or you can say that I1 is greater than I2. If I1 is greater than I3, I1 direction like this one, I3 direction this one. Okay, means here in this path I1 plus I3. and here I3. Okay, so plus minus, apply KVL in this loop. Minus to plus minus VTH. Okay, direction of current here minus to plus minus 1 into I2. I2 is 1, so 1 volt. I1 plus I3. I1 that is 2 and I3 is 1. So 2 plus 1, this is equal to 3. So plus 3 and plus 2 minus, what about I3? I3 is 1, so 1, this is equal to 0. So VTH, this is equal to 4 minus, that is 3 volt. After that, plus minus, and that is RTH, and here RL is 1 kilo ohm. VTH is 3 volt. RTS is, what about RTS? That is 3 kilo ohm. Here X, here Y terminal. Okay. Apply voltage divider rule. Whatever, and that is V naught. So V naught is written as VTH 3 into 1 divided by 3 plus 1, that is 4. You can say that 0.75 volt. Okay, 0.75 volt is the final answer. Okay, so simply how can do it? First of all, our motto determined V naught. So we have considered this here X, here Y. This one is converted into Thevenin's equivalent, that is XY, RTH and VTH. After that, determine these value. VTH is positive, that's why here positive, here negative, and RTH is 3 kilo ohm. Apply voltage divider rule. V naught, we got V naught, this is equal to like this one. What about voltage divider rule? VTH into RL divided by RL plus RTH. Very simple. Okay, after that, putting this value and find the answer. 0.75 volt is the final answer. Make it.